This particular part, ladies and gents, okay, is the flywheel. There are two identical flywheels to be made. These particular flywheels are made out of 2011 grade machining alloy. It is very, very precise in its diameter, but you will need to measure the thickness before going and machining those particular parts. Some parts to note on this particular, or some details to note on this particular drawing are the two holes. Okay, we have a hole slightly offset, and we also have a hole on the little boss. More details will be given to you in the actual demonstration of machining those parts. Here, ladies and gents, we have our two billets of raw material for our flywheels. Please note that the diameter is identical, 50 millimeters in diameter, but the thickness may vary due to the actual cutting process. Please make sure you measure each individual piece before machining. Alright, welcome ladies and gents to the actual machining demonstration for the flywheel. Just a couple of things to refresh you on the metal lathe here. Okay, the metal lathe chuck is driven by the actual chuck key. Rules on the chuck key, you never leave the chuck key in the chuck unattended. Okay, so please remember that. It must always be removed from the actual chuck. Do not leave it in there unattended. Safety glasses will be worn for this particular machining part, guys. No loose clothing on here, and obviously your hair restrained and wearing correct and appropriate PPE. First thing is, ladies and gents, we're going to take our raw piece of billet material that we have here, okay, and we're actually going to measure that particular thickness. So make yourself a couple of measurements. Don't just measure one spot and assume. Make 2 or 3 measurements. Okay, so we're 16.8, 16.8, 16.8. Just make sure you write that down so you have a reference object to go off. What we're going to do, guys, is we're going to machine this particular piece down to 15 mil, but it won't be done in one particular pass. It will be done in a couple of different processes. There is a jig for this particular machine, or this particular machining task. Note the split in the actual jig. Inserting the material. Place the actual machine jig into the metal lathe, making sure the split is located between two jaws. Don't put them on a jaw. Make sure it's between two jaws. Just firm. There's no need to be over tight with this. Just firm. The actual tension on the aluminium will take up any slack. Closing our machine to make sure our guards are in place. We are machining this particular job at around about 1200 RPM. Okay, so our speed will be rather quick. We're going to start the machine up. We're going to come into our surface or our face. We're going to zero our particular metal lathe or our particular digital readout. We're going to take 0.5 of a mil. Nice and steady all the way through to the centre. Once we're done with that particular marking there, ladies and gents, we're going to make a small indentation into the face of our job. We're going to be using our tailstock for this. We've got our Jacobs chuck in place. We have our centre drill. Our centre drill is that goofy style tool that you've been shown in the previous demonstration. We're only drilling to the second set of shoulders. Okay, locking our tailstock in place. We're going to make our mark about 0.5 of a mil deep. Stopping our machine. We're going to paint that face in the area that's required for our little scribe line. Now our scribe line here, ladies and gents, is for our actual offset dimension. Our dimension is 8 millimeters. So what we're doing here is we're going to use our actual rule. We're going to use our actual set of dividers, and we'll actually space that distance using a known dimension. Once you've gained that dimension, placing the actual points into the actual centre we've just created, rolling the chuck by hand, no power is required for this, and we'll get our scribe line. Closing our machine back up again, We're now going to drill a bit deeper to our secondary set of shoulders using our actual centre drill. We're now placing, according to our CAD drawing for our Stirling engine, our 5mm drill. And we'll be drilling all the way through our particular billet.